Welcome to Talking Kotlin. Hey Seb, how are you?
I am excellent, honey. How are you?
I'm good. I'm good. Yeah, me. I'm me. I
You
don't know what
look
that means,
you
but
look excellent today. I gotta
thank you.
say.
I've been working out. You know me.
Always. It
Yeah.
is it is it is known.
I've been like doing bike lately, and then I found out that the video camera has to focus on my face and not my legs, so I can't show you what I've been working out. But yeah, it's been fun.
We should have gotten some sort of like mirror set up so that people can see
There's a
you
little camera at
in
the
all
back
your
looking at my
glory.
legs.
Yeah, multi-camera setup type thing.
Yeah.
Maybe that would,
Anyway,
change the viewing rates for our video. Who knows?
yeah. So, how you been? How
No,
have you
I've
been working out? I heard you maybe had a little miss fall or miss lift.
I've been doing a little bit, yeah. No, I've been getting into some like trying to get some more upper body strength stuff. And I got a little too excited a little too quickly and I messed up my shoulder. So now I'm sitting there every morning and I'm like, I would love to do my workout, but I should also rest my shoulder. Um, but hey, we'll come back from all of that.
Yeah,
Not
rest,
worried.
recovery is actually a very good thing. Like I recently got a new watch that says to me after a workout, it says like recovery time, and it's like I do a workout for an hour, it says recovery time 3 days. I'm like, damn, am I like in such a shitty shape that it takes 3 days for me to recover? But anyway, so listen, today is a very special day, isn't it? Apart from that, we have two guests which we'll announce soon. Today is also, what is it, Seb? What is today?
It's the end of an era, I would say. It's the last time that we'll be hosting together as co-hosts on Talking Kotlin, at least for a good while, right?
Yep. Today, unfortunately, is the day that you need to leave. You didn't see that one coming, did you?
Actually, you
No.
turned that one around on me.
Yeah, no. Today is actually the day that is going to be my last Talking Kotlin episode that I'm going to record. Well, maybe you invite me sometime back as a guest, but as a co-host, it's my last one. And it's been 8 wonderful years. A little bit less because some of it was with you. But it's been really, really fun, and I really enjoyed it. But it's time for me to move along or move on, and we're going to have a new host, which you will announce at some point when the new show comes up. But
That's right.
for me, it's the last one. But don't worry, I come prepared. Look at this. Look, I got a box of tissues.
Is that
Right.
today's sponsor?
Well, Carrefour tissues. Sure. Yeah. Um, I got something if the tissues don't work, which ironically makes me cry if I drink too much whiskey.
Aw.
And we can always, what is always missing? Protein bars. Yeah, so there's the protein bars, which is our, once we get real sponsors, no one's going to know if we're joking or not with the sponsors. But yeah. So anyway, talking about protein bars, let's give way to our guests, who are two massive proteins. Yeah,
What is what? You want to try that again?
oh yeah, sorry. So I know that one of them is actually a vegetarian. So one protein and one carbohydrates.
That's. I don't think that's how that works. We're really excited to have Misha Zarechenskii and Egor Tolstoy on the show today. Hey, folks, do you want to briefly introduce yourself, maybe? Starting
Who's
with
the
Misha.
protein?
Hi, Seb. Nice to see you. My name is Michael. I'm leading the language design in Kotlin. So basically, I'm just trying to answer all the questions on UTrack and on our Kotlin design channel and everywhere, and also to understand how we integrate and fix the core issues of Kotlin and all that stuff.
Yes, and I'm Yegor, and despite being vegetarian each day, I eat about 200 proteins because you know that tofu is very rich in proteins. So yes, and besides like eating whole tons of tofu, I lead the Kotlin team as the Kotlin project lead. I'm responsible for such things as planning, roadmaps, product, and all of the everything that is not language design.
We need to. I need to sit down with you one day, Igor, and discuss. Like, have you seen Forrest Gump?
Yes.
Have you seen the movie when he's like, the prawn? You could do so many things with prawns, like prawn cocktail and prawn barbecue. You got to tell me the equivalent of tofu. Like, you could do so many things with tofu, right? And I'll pick up some more on the tofu front.
Sure.
That could be my next podcast. Like, what can you do with tofu?
Does it barbecue?
Yeah. Anyway, guess what also happened since we've been from the previous show recording, whatever that means, published. CotlinConf happened, didn't it, Seb?
It sure did, and it was quite the event with tons of announcement. And notably, both Igor and Michael were also on stage during the keynote at KotlinConf, of course, and told us a whole bunch of things about what's new in Kotlin. First and foremost, of course, there's been Kotlin 2.0, right, with a new compiler and everything. But at this point, what I think we're curious about is first of all, how do we get to Kotlin 2.0, and then where are we going from here, right? So how do we get to Kotlin 2.0? I'm just gonna throw that one out there as an open-ended question, and we'll go from there.
So we always wanted to have Kotlin like enjoyable and like applicable for large code bases, and especially for multi-platform things. And one funny thing is that multi-platform projects appeared right after the release of the first Kotlin first version of Kotlin, and some things were not that ready in the compiler, and we didn't expect some large refactorings and how like different like platforms will communicate to each other. And while we had to release the first release of Kotlin that year, we also wanted to make a few refactorings after, and it appeared that such refactorings will lead to like a large refactoring in the compiler and in the whole architecture, that we have to release the almost the new compiler. So the next few years we had to rewrite like JVM parts, like web parts, and also the front end part of the compiler, which will result in the whole new compiler, which is nowadays we call Kotlin 2.0.
So I have a follow-up question to that, but to Igor. Uh, you spent a fair amount of time rewriting things. How do you manage to move the product forward, or did the product move forward at the same time while you're doing a lot of housekeeping? How do you do that as a product manager? How do you balance that?
Well, these years were perfect for me as a product manager because we essentially postponed all features, so I just
Okay.
I just was able to rest. No, I'm joking. Well, actually, I'm only half joking because we intentionally avoided introducing any new major language features in Kotlin 2.0 with the specific intention to make the migration like as smooth as possible and avoid splitting our community into two parts. You know, folks who use Kotlin pre 2.0 and folks who use Kotlin after 2.0. So we didn't introduce any new huge features, but still we did like lots of how to say it, housekeeping stuff. Like we continued to work on performance problems. We continued to fix like different corner cases in the language that we were able to. We continued to improve IDE experience. So like we still made lots of efforts in improving on the tooling front, but we worked very hard to not break your language related experience.
Yeah, and in addition to that, I can say that we ended up with about 100 features in Kotlin 2.0 because we made smartcasts better or smarter. We improved type inference stuff and many other smaller features.
Okay, so that's really. But when you talk about, for example, the smartcast, that pretty much just means like, okay, the language is now like more correct. Like it can provide more inferences, which doesn't like change anything or doesn't really break things for people. It just helps them, or it helps the compiler understand better uh, whether a specific type of code like can be reasoned about, I guess. But one of the questions that I would have here is how the reception of this overall choice was to like not move forward with like large language features quickly, but say, hey, we need to do like some engineering to build on like a solid base. How was that received?
I can say that Kotlin is a pretty good language and it's still like very modern. And we and it's also usually people understand that if we invest more in architecture, it will pay off in the end. And this is what we did, and we try to explain that actually we are not going to stop on language features and the design. It's actually vice versa. We want our architecture to be able to handle all those features that we would love to add to the language. And if you want to save the integrity of the language, we have to do all those refactorings and change some of our decisions in our core compiler.
Yes, and besides it, I believe that we did quite a good job explaining what future benefits Kotlin 2.0 will bring. Besides just explaining what language features it will be possible to implement with it, we also spent quite a lot of time communicating performance improvements, specifically around the ID experience, and explaining how the new K2-based IntelliJ IDE plugin will be rewritten on top of the new compiler, and what performance improvements it will bring. By the way, it's already in beta with an IntelliJ release, so try it out.
So you kind of did pre-marketing, so to speak, in a way, right? Like we want to focus a lot on housekeeping, cleaning up, preparing for the next wave of language features and building upon for the future. And you need to kind of set expectations for users in a sense also, right? There was a lot of preemptive working. No, preemptive isn't the word, but there was a lot of work done beforehand to kind of like guide people in this direction, would you say?
Yep.
Yeah, which is fine. Like we did something similar with ReSharper 5 to ReSharper 6. It's one of our products that needed major cleanup under the covers, and we spent like a year just promoting, hey, cleaning up your code is a good thing, people. That's what ReSharper does for you. So we're now doing it to ReSharper.
So with the Kotlin 2.0 release, is that work now done? Like, would you say, okay, we have everything cleaned up to the point that we want to, or is there still stuff that like needs to be done on the cleanup perspective, not on the feature perspective?
Well, usually as it happens with like programming and like that, the work for programmers apparently never ends. So and we still have a few leftovers. And what is more interesting is that now we have a lot of stuff that we want to do. So for example, right now we have like a cleaner architecture. We want to provide some compiler API. So, and also we want to provide some new version of KPT. And also we want to provide more actual modifications and refinements. We want to provide features. And the problem right now actually is to pick the correct, the more prioritized things that we want to work on. So on the one hand, yes, we have some leftovers, but on the other hand, we actually now have way more things that we would love to do.
Yes, and even from the technical depth, let's call it this way, perspective, we still have quite a few areas of improvement inside the compiler, which is now easier to fix thanks to the new architecture. But still, for example, inlining works a bit differently in JVM and native backends, for example, and this is something that we want to focus on in the future, and a couple of other areas like this.
And you mentioned that there's a lot to work on. And as a product manager yourself and product manager for Kotlin, how do you decide? What's the process that goes into figuring out what to work on? How do you prioritize things?
Our primary guiding factor in prioritization is what actually our users need. So we as product managers do like lots of surveys, talk to people in the community, talk to different companies, and try to understand what challenges they have, what issues they face with Kotlin, what issues they may face in the future. And we try to optimize our backlog based on this understanding. So basically, we listen to what users say and we do everything to make them happy, and that's it.
Sure, but I'm not going to let you off the hook that easily because users want everything, right? I mean, if you look at UTrack, every other thing is voted massively. If you look through Slack, everyone's complaining about X. How do you, at the end of the day, prioritize that backlog? What comes into play? Is it just UTrack votes? Is it just the loudest person with comments? How does it work?
Okay, let me describe the whole process.
Yes, make
Uh,
it boring.
Yeah, it's a bit different from the language features perspective, and I will let Michael cover this part. But for general in Kotlin, we do it in the following way. First, we have a so-called strategy document. That's our vision of our team of how the future development in Kotlin will look like, what things will matter in like 3 to 5 years to come, and where Kotlin falls short into delivering in these areas. So we understand like the future state of things, where we are now, and the leap behind these two states. And then we together, it's me, Michael, some other product and engineering leads of Kotlin, come together in a closed room. We close all the doors, and then we argue for like 16, 20, 24 hours or more about what things first provide more value given this strategy, second what will the effort be to deliver them, and then we try to balance value with effort. We try to pick things that that it's better to deliver together so that we have one focus as a team, and then here is a backlog.
Okay, that sorry, and I'll let you ask a question now, Seth. But the very important follow up, because that explains something that you showed us before we joined the recording. Egor, can you lift up your bottle of water, please? That explains why you're locked in a room for 24 hours.
Yes.
It's like I come prepared.
So I do have just I want to rewind just a little bit. Michael, you talked a little bit both about the compiler API and KAPT, so the Kotlin annotation processor, right? Can you maybe give a little bit of perspective why, well, first of all, why a compiler API is important and what kind of work is being done on capt?
One of our like core principle of Kotlin is to provide a platform, and compiler API is the store which you can use to provide and achieve this platform principle. Because this is actually one of the things that also makes Kotlin great. Because if you take a look at the Compose compiler, it's actually just it's a compiler plugin for the Kotlin language. And we also know that it's possible to like explore more domains, providing dedicated compiler API. Because we as a Kotlin, we are focused on the core things that will like applicable for almost all users. But it's clear that you could also add things, or someone else could add things for some specialized things and for specific domains. And the same approach could be used, for example, for differentiable programming or exploring type system, because right now, like, there was an interesting project where it's possible to multiply matrix in a type-safe manner, and it was done via compiler plugin. And we believe that if we provide clear compiler API, this will be also compatible across different versions, then people will use it to create their own extensions for the language. And maybe some of those languages will then just will take that to the core language. For example, as it almost happened with PowerAssert plugin, which was written as a compiler plugin, and now we see that people like it, and we also like it, and I think it's a great thing to have in the language. So we took it closer to us and put it in our repository. And we also think that at some point we'll take it to the language itself.
Yeah, by the way, that's really connected to the previous question about how we prioritize things. So we tend to look at Kotlin not just as the language, but as an ecosystem where besides the language, we have different libraries, frameworks, and tools, and all together they help a developer to build wonderful applications, be it server-side, client-side, or anything else. But there are like lots of different domains where you can build applications like desktop, server-side, mobile, console apps, Minecraft mods, like tons of them. And we can't here in JetBrains in the Kotlin team, we can't provide like building blocks for every area. So as Michael said, at some point of time, we decided that we must look at Kotlin as a platform that should empower other people in the community to create some other great tools over Kotlin. So that's why we're investing in different extension points. Compiler plugin API is one of these points. Another one is the most obvious one. It is like libraries. So that's why we have a like dedicated team working on library authors development experience. Another potential extension point is an analysis API on top of which you can potentially create different linters and stuff like this. So like this is very important thing to understand about Kotlin. We even if we prioritize some things like server-side development in the Kotlin team, still we want Kotlin to be a great general purpose language, and that's why we empower community to build wonderful stuff on top of it.
Yeah, and I think it's really important to mention that, like, when we think about Kotlin, a lot of people just think about language, but it's so much more. Like, folks have I don't know if they have a clear understanding of the scope of the many products that fall under the Kotlin umbrella, right? From the build tools to CAP to anything that you can think about, right? It's more than just language features.
Yeah, it's like really much more.
Tooling.
Yeah,
Tooling. Oh, what's the
documentation.
company that does tooling? Oh yeah, documentation.
So I do want to briefly follow up here on a couple of things, because yeah, we've kind of jumped through quite a lot of subjects here. You talked about the compiler plugin API as an extension point, for example, for different ways of programming, like differentiable programming, automatic differentiation, that kind of stuff. If someone is interested in learning more about this, I know that there's a Facebook research project called DiffKT, and then there's also Kotlin Grad. I don't know if there are other ones that.
There's also a Talking Kotlin episode that I recorded with Eric Meyer on the topic.
Look at
Differential
that.
programming. Yeah.
That was before my time.
Why do you
You
think
really
I'm
ha-
leaving now?
you have quite the legacy. Are there any other ones that are like maybe worth shouting out if people are interested in this, or are those the like main ones?
I think that these are the main ones, but like at some point when we decided to understand, like, well, there's a new compiler, and of course the old compiler plugins stopped working. So we have to like tell the authors of those plugins that they have to migrate. And at that point, we decided to understand like how many plugins are there. Like maybe that's 10 of them, and that's it. And when we checked it, like even we tried to use like our GitHub repository, like open source projects, it turned out that there were like a few hundreds of compiler plugins. And in most cases, they're just like making like some small thing. And usually it's, especially if it's in enterprise, you want some small annotation processor stuff, or some logging, or some you want to distribute your caches. So it's usually not applicable for like many users, but it can really work well for your cases and for your company's cases.
And then one of the other ones that you mentioned was power assert. Now, if people have followed the Kotlin conf talks and like our recent announcements, then they probably already know a little bit about what power assert is. There's a pretty nice lightning talk on power assert during that. But in just a couple of words, can you maybe just describe what power assert is so that people get a bit of an understanding of why it's really awesome to have, and especially why it's really awesome to have bundled more closely with the language?
It actually lowers the cognitive friction when you are writing tests. So for example, if you want to write some assert with like expert.foo equals to 5, then it will fail if it's if it wasn't equal to 5, but it won't be clear like what is the actual value was of expert and what is the actual value of foo. And right now in our current world, in order to solve this, you have to put expert and like foo to pass them as different parameters, and 5 as a different argument. And then the testing framework will show you that these are actual values, and then you don't have to debug the code, your test. It's clear that which values were assigned to those expressions. But with power assert, you don't have to write and pass them as different arguments. You can use naturally and write natural code with export.foo equals to 5, and the power assert will show you the complete debug log of those expressions and which are values were assigned to them. So it becomes really easy to write tests and understand what's going on if your test is failing.
So with that, I get to kind of avoid having to have like an assertion library where I need to like have a different function call if I'm comparing two collections versus I want to have like I don't know, set membership just so that I get a nice output. Now I can just always assert some sort of condition, and power assert will just, I guess, transform the underlying code in a way that I get a as the failure message, I just get a nice diagram of the actual values and what has failed.
Right. So you don't have to learn how your framework works, and you can write the same code as you write it in your application.
I mean, that's true. Yeah, that's truly excellent. I still remember when I first saw it, I was like, this does seem a little bit like the kind of magic that you enjoy in programming, like something where the machine just does the work for you. Now, just as maybe a little bit of guidance for people who are getting like starting to itch to write their own like compiler plugin or annotation processor or so on.
Don't do it. Is
I
that
mean,
the guidance? Don't do it.
maybe that's the guidance. But we also like there's also KSP, right? Like the Kotlin symbol processor, which, as I understand it, has like a simpler API, has a couple of like limitations. So my question here is with Kotlin 2.0 and going forward, is KSP gonna stick around? Is it still the best choice to always go for KSP if you can? What's the situation here?
Right. So if you want to write or to have an annotation processor, then it's way better to start with KSP, because KSP is like a lightweight. It allows you to write lightweight compiler plugins or annotation processors, and it has a stable API, and it's our one right now. It's one of our main focuses to make the API there stable, so that you can upgrade, for example, Kotlin compiler and not worry that your KSP plugin stop worked after the upgrade.
I think we need to do. Sorry.
Go for it.
Well, I made a terrible mistake. I said I think we need to do an episode just on power cert, and then I realized I'll never be able to do that. I think you should do an episode, Seb, in the future on power cert.
That sounds like an excellent idea, Hadi.
Yes,
You
I'll
seem to
charge
have a
you
lot
for
of
my
experience
ideas.
in this subject. So
Yes.
just on the topic of, I guess, compiler plugins, I still have one more question, which is regarding the Compose plugin, because that was also one of the big announcements, kind of happening at the same time as Kotlin 2.0, which is that the Compose plugin is part of the Kotlin repo. But I think just having this statement stand on its own might be a little confusing for people, because that could mean like, oh, so now any Kotlin project is a Compose project, or it's now always mandatory to use it, or what exactly does this mean? So I'd love to have some clarification from you folks about what it means that the Compose plugin is now part of the Kotlin repository.
Yeah, so because Compose plugin is a compiler plugin for Kotlin, and it's quite tightly connected with the compiler, it was hard to depend on the Kotlin compiler, because if you want to release a new version of Kotlin, then the Compose team had to release immediately a new version of Compose, because the API usually wasn't compatible with the previous version. And right now, because we still don't have that stable compiler API, we decided that the best option is to put Compose right to the Kotlin repository. And now they have source dependency between each other. And right now, if we want to change some compiler API, we'll automatically change the parts in the Compose, so that, and when we release a new version of Kotlin, we can immediately release a new version of Compose compiler plugin. So it doesn't mean that every project is now a Compose project. It just means that we ship the Compose compiler together with the Kotlin release. And basically, what we do with, for example, Kotlin serialization, we also, with each release of Kotlin, we release a new version of serialization plugin.
And that's actually why we would not recommend anyone go and write new compiler plugins right now, because basically we cannot provide you with any guarantees. Things will break. It will be very hard to maintain this plugin, because as you see with Compose, the only viable path forward was to merge it into the Kotlin repository, and we probably won't do it with your new compiler plugin. So basically, our further plans regarding the compiler plugin API, it is understanding what can be the surface of this API that we can provide some guarantees on going forward, and at least understand if it is possible at all. So we cannot say right now that we are going to stabilize it, because it can be it can take very different shapes. We cannot expose everything that is inside our compiler, and we cannot just provide you with one or two functions. So we have to very, very carefully understand how it should look like, what extension points are needed by compiler plugin authors, and then understand if it is possible to first provide guarantees and some backward compatibility, and second, not halt our own compiler development progress, because when we start providing some compatibility guarantees, it means that we ourselves in the compiler team won't be able to move as fast as we're used to.
I just had a thought as well. Sorry, the marketing side is in me. We could do another short for this podcast where we just take a clip of what Egor said. Is we do not recommend anyone use it, because we're constantly breaking things, and people won't know if it's referring to Kotlin or the compiler plugin. But But talking about being in sync, what is the relationship between, because obviously you want to, when you're working on a language and you're also the company that's working on the tooling, you also want to avoid a situation where a new language feature appears and your code is read. How do you make that happen in sync? Much the same way where we're talking about, keeping the compose compiler plugin in sync with Kotlin. How do you keep in sync language features with tooling support for it?
Like, first of all, there are different incompatibilities. So the thing with like source compatibility, when your code just became red, is just the simplest one. Because in this case, we just gradually like outlaw some constructions from the language. And we, for example, you can use our IDE to mark some expressions as yellow and like provide automatic migration tool. But in most cases, we actually just can be creative and avoid such situations at all. So in many cases, we don't, and we are not going to break your code and make it red. Only, I'd say that only in cases when we want to like slightly change our type inference engine, or like, for example, we want to make smart casts smarter, and then it can be resulted that more specific overload has been chosen. But if you want to introduce a new language feature that will make your code red, then maybe it's not worth it. But usually, so we want to make sure that like if such a feature will break your code, will it worth adding it to the language or not? Because in some sense, we'll break the integrity, and now you'll have like a few like ways to do the same thing with this feature and without. But if we really want to, we can like gradually migrate your code by adding warnings and then errors and then change the behavior.
Looking at this, I think it's maybe worth taking a step back and actually maybe just asking about this as a more general level. Of course, compatibility is one aspect, but do you have a set of, let's say, guiding principles that inform how you add new things to the language, like overall?
Again, if you want to break something in the language, we have this process with the Kotlin language committee, where, like, first of all, we have to fill this form and explain in detail, like, what is the kind of incompatibility you want to introduce in the language. For example, it's source incompatibility, runtime incompatibility, or binary incompatibility, and then in like which projects it will affect, like how many usages we can find, for example, in our open source repositories. And then, for example, me and also Jeffrey and Werner, again, like we are looking in a room and discussing those issues, whether it's fine to proceed. And for example, how many releases we can show the warning before turning the actual change and make the code red. So and this process is, it's needed to make sure that there are independent reviewers of such changes that will check also their code bases. For example, we can also check like Google Tree before making such a change and understand how many usages will be broken. And in many cases, like it's relatively small, so that in most cases that people do not won't see such changes in their projects at all.
Just to clarify, you mentioned a few names, Jeffrey and Werner. So for folks
Right.
that don't know, this is two folks that are on the language committee of the Kotlin Foundation, which has a committee specifically for overviewing breaking changes in the language, right?
Right.
Yeah. But before that step, you also mentioned that you discuss it. So you first have a discussion internally within the language team inside JetBrains, inside the Kotlin team, and then
Right. So usually it's either a compiler developer brings such a change that, for example, we want to So there's a motivation part why we want to make such a change. It's either we want to make the language more consistent, or it's important for the sake of optimizations. For example, we know that some features, and especially again in type inference, can slow down the compilation time. So sometimes we want to make it dumber a bit, and as a result, some code will be rejected by the compiler. Or we want to introduce a new language feature, and for example, or change our core one, for example, as we want to do with name-based destruction. So because we want to outlaw some constructions with like positional based destruction, we have to motivate all our changes, because it will be more clear, it will be type safe, or it will be like it will be easier to compile such code without that feature. So that's the first part. And this part, yes, is discussed within the Kotlin team. We also do the preliminary checks, and we check for example, our Kotlin repository, like our IntelliJ IDEA repository and Kotlin X libraries, whether such pattern happens there or not. And then, we pass this change to the language committee, where we discuss it one more time with Jeffrey and Werner.
I will add my couple of cents here. So basically, each question about adding a new language feature to the language is always a trade-off of the value that this feature will provide to a user and costs that it will bring together with it. For example, mental cost in having to learn a new language concept, or like cost in making our tooling more complicated to handle this feature. So each step of the language evolution process, it helps us to remove uncertainty around the value that this feature will bring. For example, on different stages, we like collect feedback from people, asking them, what do you think about this prototype? Is it helpful in your use cases or not? Or we even sometimes conduct UX tests, where we design like a series of code snippets with the proposed language features. We show them to selected folks, and we ask them, like, for example, what the output of this snippet will be, and then we see if they interpret it correctly as we intended to or not. So steps like these help us to define the value of this feature. And about the cost, Michael already covered some of the ways to understand the cost of this change. Another one, for example, is analyzing all of the existing open source repositories on GitHub. We have a special tool that allows us to make queries to all of the Kotlin repositories and understand how often like a specific pattern appears. This also helps us to understand like how much code we will potentially break. So basically, this is a multi-stage process. On each stage, we try to build a better understanding of value and associated costs for the feature.
All right. So my question that's maybe taken even a step further here is like from a vision perspective, though, like not just based on like the individual features. Like what is the general direction that you see like Kotlin heading into, like the kind of I guess maybe some like leading the principles that where you're like these are areas where Kotlin should excel, or these are typical tasks that Kotlin should be just absolutely excellent in. Is there anything in this area that you have?
I can start with like overall ideas, and Michael can cover like from the language perspective. So we believe that Kotlin is a perfect application development language. So this is a choice that we deliberately did. For example, we are not focusing on system level programming. There are other languages right now that do a better job there, but we want Kotlin to be the perfect choice when you want to create an end user application, independently on where it runs, be it on the server side or be it on any client-side platform with a user interface. So this is the first thing. We want Kotlin to be a great application development language. Second is that Kotlin is targeted at how can I call it? Real world programming. So we do not like introduce, for example, new features just for the sake of introducing some interesting new, like on the edge programming concept. We look at challenges that real people face in their real worlds, and we want Kotlin to help them overcome these difficulties. So that's like the second principle that we have. The third principle that we have is something that we've already described. This is a platform principle, where we want Kotlin to be like a platform on top of which community delivers great new frameworks that make it easy to use Kotlin in like different domains. Regarding specific focuses that we have right now for Kotlin, the first one is server side. We believe that Kotlin is a perfect choice for creating server-side applications with complicated business logic, where you have to like where you have to do multiple complicated operations on different types of data, transform it in different ways, move it between instances, and so on. So we really think that this is a place where Kotlin shines. The second one is multi-platform development, which also includes server-side in it. But still, Kotlin has lots of features that make it much easier to share code between platforms. So this is a direction where we're following into, because we don't like the current situation where you as a business have to have many developers actually creating the very same thing for different platforms. 10 people for web, 10 people for iOS, 10 people for Android, all of them implementing like the same code. That's very, very strange. So we want to fix this.
So talking about multi-platform, how does that aspect actually influence decisions that you make in terms of implementing new language features? Like, let's say, for instance, that there is some language features that would be impossible or nearly close to impossible to implement on a specific platform, and yet would benefit 5 of the other platforms. Do you discard it? What do you do?
Usually it depends, but in many cases we discard such features. For example, one of the main examples here is value classes. For example, we could implement them, or structs, we could implement them for Kotlin native, but because we don't want to, because it's quite impractical to implement them right now for Kotlin JVM, we discard this feature. But at the same time, like value classes are really nice. It is a really nice fit for Kotlin because, for example, for JVM, we have non-nullable types by default, so the JVM will be able to optimize them correctly without the need of like special marks with like exclamation marks, as it was proposed for Java recently. Or for example, we know that value classes can be used for some numbers and unsigned arithmetics and other stuff. And here also Kotlin shines with operator overloading because, again, it's possible to overload like plus, multiply, and like all other operators and write natural code. But we are waiting for the Valhalla project because if we implement value classes for JVM, we know that we'll break users after the Valhalla lands in JVM world. So yeah, in many cases, we just discard such features, unfortunately.
There's a couple of other features that you mentioned at KotlinConf in your talk, which, by the way, is also available on the Kotlin YouTube channel if you do want to check that out. But you already mentioned some stuff around name-based destructuring or making it easier for folks to do name-based destructuring. But there's one other pretty big point that I think might be quite exciting for people, but that might also be maybe slightly confusing at first, which is union types. So, of course, like Kotlin is not the first language to do something in the direction of union types. In fact, a bunch of other languages, right? Like if you look at TypeScript or whatever, you can just put a bunch of like pipes between type declarations, and then all of a sudden, magically, I don't know, a return type can be one of 3 different classes, and somehow a type checker maybe makes that work. As I understood from watching your talk, we're not quite going the same direction. We're not going full union type support, but we are introducing them for working with exceptions. But could you maybe explain a little bit, like, what kind of the design concerns here were, and why we're not just going the way of saying, okay, like, union types 100%, let's go, do whatever you want?
So you're right that the story is connected to the exceptions, and we always tell people that main use case for exceptions is to handle logic program errors. And since it's like logic, so it's usually for some preconditions and checking invariants. And it also means that if it's used only for logic program errors, then you don't have to catch them. And because it should be catched like at some like top level by a framework. And if you have like some failure scenarios, then you can use, for example, nullable types. And if you use only nullable types, then everything is fine. But what is a nullable type? It's just some value t or null. And for that case, we have, for example, nullable operators, and you can write chain calls, and functions can return like t or null, and everything works fine. But if you have, for example, several failure scenarios, then it stops working. And right now, to make it really safe and more or less clear, you can introduce field hierarchy, which is more or less fine. But in this case, you will lose. You won't be able to write those chain calls because you don't have those operators. You'll have to like invoke a method, then write a when expression to understand whether it's like a failure or success. Take the value, then invoke the next method, and so on. And that is not that clear. And because we don't provide a good mechanism to handle like errors in general, people start using exceptions here and there, and then it becomes kind of a mess sometimes, because we don't have, on the one hand, checked exceptions. On the other hand, we don't provide like a clear mechanism to work with errors when we have like several failure scenarios. And again, you see that if you use nullable types, for example, for your failure scenario, then everything is fine. But we want to make the next step. We want to generalize that. So we want to say that now we can return not only like t or null, but also t or some failure 1 or failure 2 or failure 3 and so on, and provide special operators to work with such functions, so that it will be possible to combine them and then at some point understand, take the values or disregard the value and work with the errors. So yeah, and this is where we think that union types can help us, and that is quite interesting, because that's like the most pragmatic aspect of union types that I can see right now. Because the other aspect is to use union types as parameters or as input types. And this is the case actually of overloads, because if you want to write a function that takes, for example, int or string, it basically means that you want to write an overload, two overloads, that one of them takes int and the other one takes string. And this is not, we believe that there can be a slightly different feature that can do the same, which is called, we don't have a name for it, but in Utrecht we find it by looking for declaration side-defined conversions. And this is a quite complicated thing, because with those union types, you want to say that there is some relation between int and string, and I have some conversion function between int and string, and I have to invoke it every time. And this is the way that we don't want to go. So right now we are focusing mostly on union types for errors. because we believe that it's the most pragmatic way. And there is a problem right now in Kotlin that we don't have a clear mechanism to work with errors. While with overloads, you can write overloads. It will be just a little bit, maybe not that pretty, but it's possible and good enough.
But they're not going to be union types in the full like flexibility that you might know from, for example, TypeScript, right?
Right. So it will be possible to create a union type between a value and a bunch of errors. It won't be possible to create like union between, like, again, int or string. It will be always like int or a set of errors.
Okay. But I mean, as you mentioned, I feel like the real value here, where union types for these kind of error conditions are really going to shine is when there is a set of operators, like you mentioned, that make it easy to work with those errors. Because I think like this is also kind of like on a library level, I guess. Like typically result or either types kind of try to do this as well, but maybe not in the most ergonomic way. Certainly not in a way that's supported on a language level. So there's definitely some cool benefits here. One of the other subjects that I'm just still curious, because I mean it's rare you get to talk directly to the folks who are so super involved. From a Kotlin language design perspective, do you feel that there are any parts of the Kotlin language where we're kind of stuck with a suboptimal solution? Like that's kind of a core part of the Kotlin language that's maybe now we're at the point where like, well, everyone depends on it, like can't really change it anymore. Is there anything like that that you would change if you had the magic wand to go back in time and do it?
Actually, not that easy, because I can say that, for example, I would love to change companion objects, but at the same time, if you try to explain this concept to a newcomer, then it's pretty easy, and there are no problems, no real problems with companion objects. Besides that, we don't have the best interop with Java, and that sometimes we can't like add extensions on third-party classes. But otherwise, this is a pretty nice concept, and as an advantage, we don't have static concept in our language, which is usually abused and overused. And you know that sometimes static can mean like a few different things that are completely different. And a few things that I would love to change is probably about inline functions and suspend functions, because I always like one of the things that I like in Kotlin is that it was made with tooling in mind, but inline functions make it quite complicated to debug and for them to introspect and to profile code when you have to have them in your code base. So probably I would love to change, yes, inline functions and suspend function generation a bit.
So, Igor, as a product manager, what's your opinion on that question?
My opinion is that Kotlin is perfect from like any angle that you will choose.
Said the
Sure you're
product
not?
manager.
Yeah. Are you sure you're not part of developer advocacy or marketing or?
Sometimes you have to take different hats.
Okay.
Anyway, 1 hour. Wow, 1 hour. This is going to be like one of the longest episodes we've done, and I know it's my last one. I didn't bring a glass. Can I just go straight from the bottle? And it's only, oh, it's already 1 o'clock. I can drink. But no, we have to wrap up. We do have to wrap up. And there is still one question that I think some people may be wondering. So, and I want to ask it because, you know me, I like difficult questions. So at KotlinConf, we had a panel. During the closing panel, someone asked a question of, there's been I can't remember exactly, but it was something in lines of like there's been a bunch of different folks that have now changed as the lead language designer. And now we're in a different style where we have a lead language designer, which is Misha, and then we have the project lead, which is you, Igor. Could you kind of explain a little bit why this approach and what the benefits you believe are in this regard?
Let me try to summarize it. Um, well, Kotlin is a quite big and complicated project and a team, and in order for it to thrive, we need to be successful on many levels. First is definitely language design, because Kotlin first and foremost is a language, and it's a very huge area that requires 100% attention of someone. Second, Kotlin is a huge engineering system with many different subsystems interacting with each other that should be kept in sync and aligned, both from the technical perspective and from the product priorities. That's why someone has to oversee this alignment. Third, each of these subsystems is a very different inside and requires folks with very specialized backgrounds and knowledge in order to maintain and improve them. That's why even if you have only me and Michael on this episode, Kotlin is actually led by a team of wonderful professionals who are not together with us here. But for example, we have a separate person who is responsible for all the libraries and tooling ecosystem. We have a separate person who is responsible for compiler from the front end to all of the backends. We have a person responsible for quality and for other areas as well. So our approach is to define the most crucial parts and areas for Kotlin to be successful, and have a dedicated person to lead this part, because it requires 100% attention.
Yeah, and to add to that, I mean, even your team, Misha, is you have a team, right, which is called the Language
Right.
Evolution Team, or LET, one of the first extension functions in Kotlin that everyone started to use. LET question mark? Was that coincidence or was that planned all along? But yeah, and like the way that I also see it is Kotlin at the end of the day is a product. And what makes the language different as a product than any other product, right? It's products are led by one or more people, and I don't see any issue here. So yeah, cool. So it's 1 hour and gee, that's a lot of minus the my screw ups. So yeah, we probably have to cut half an hour from that from this recording. But
Yeah.
anyway, any final words, Seb, before we sign off and I basically disappear for the rest of my life?
It's gonna be a crisp 20-minute episode. No,
Wow.
don't worry. Well, I have a question for you, Hadi. Where can people find you if they if they haven't had enough of all the banter that you've brought to the
Talking,
show over the years?
yeah, talking tofu. So I'll be
Talking
launching
tofu.
that podcast soon. Yes.
Okay.
I would also suggest to buy tickets for KotlinConf 2025 because we'll definitely have Hadi on as the opening keynote, right? This thing
Well,
about toilets and
I think at a minimum we'll have Hardy rapping to Eminem. At a minimum, I'm not sure about the keynote, but the rapping, yes. And also, Seb and I will be doing our duet there at KotlinConf 2025. And by the way, if you haven't purchased tickets, you better make sure you do, because the super early birds are sold out. The early birds are sold out, and we're really selling well the more expensive ones. I guess that's what you call them. No, they call them regular tickets. Yes, the regular tickets are being sold. But anyway, yes. So listen, Igor, thank you for coming onto the show. Misha, same to you. Best of luck in your ventures in Kotlin. What comes next? Seb, it's been an absolute honor to host with you, and I've very much enjoyed it. And to all the audiences out there that have listened to us for the past 8 years, well, thank you once again for everything.
I'll
And in the future, do leave a little bit more comments, especially positive ones. It's like
I
the only bloody feedback we ever get.
I want to mention here as the lead out for this episode and for your tenure at Talking Kotlin. You'll always be a part of Talking Kotlin. Nothing changes about that. That I am so very glad that all these years ago you decided to start this podcast. I can still tell you exactly that the first time I listened to Talking Kotlin was the first episode from a drive home from my grandma's house. And it was one of the first aspects that has pulled me into the Kotlin ecosystem, that has made me feel like I was part of a community, that made it feel like there was just so much more out there to explore and to get better at, and to improve. And I mean, in large part, I think that also set a little bit of the trajectory for my career later on. So you've made a huge impact with Talking Kotlin, and we're gonna continue hopefully carrying that legacy on in future episodes. But I think that I'm very much not alone with this. There's a lot of people out there who have approached us over the years and have given us positive feedback and told us that they enjoy the show, and that does make my eyes water a little bit. But yeah, it was really, really an honor hosting this with you, and yeah, new things
Yep.
are gonna come. But
Well, thank you, Seb. I mean, if I had any emotions, I would be in tears right now. But since I'm not emotional, I'm joking. No, thank you. That's very wonderful to hear, and I think that we can stop kissing up to each other. But I can also say that you joining JetBrains has been one of the greatest things that we've managed to do for the Kotlin community as well.
That's really, really awesome to hear. Thank you so much as well. So thank
By
you,
the way,
everybody.
Egor, Misha, if you want to pay me and Seb compliments, you can go. No, we're joking. Anyway, we are done. So yes, that's it. Thank you again for coming on the show, and until next time.
There
Well,
will
Thanks for
be
having
me,
us.
but you. Bye.
there will be more
Bye.
Talking Kotlin. Take care, everybody. Bye bye.